Hey everyone, thanks for joining me here. And I want to start this by, it's great to see you folks here, right? And this is actually literally the first time since the start of the pandemic that I've stepped out of my house for a conference. So quite excited to be here on the stage. I don't know how my stage presence is going to be because I've been more used to looking at a camera, 2 feet away from me and doing video conferences. But here I am. Here to talk to you, as Sharon said, about open source, open data, and open cloud on Google Cloud. So that's me again. I'm Prashanth. I head developer advocacy in Google Cloud for emerging regions, essentially take care of India, Southeast Asia, and LATAM right now. And I am myself a developer advocate, right? So I do believe in being close to technology, and I do a lot of work on some of the topics that Sharon mentioned just before this. I'm also available on Twitter at @KSPrashu, so later, if you want to contact, reach out to me, always available. I want to start this with a small story, and I have sort of a demo to go, which I seem to have recorded at about 9:40 yesterday night, so freshly cooked demo. This is about, this incident actually got me thinking, right? And that's sort of inspiration for this topic. So sometime, I think during this Ganesh Chaturthi festival time, right, my mom was doing some part of this bhajan group in the society, and she had got this printout of the actual bhajan that they were going to sing. The font was very small, it's difficult for her to read, and she asked me if I could just help enlarge it and take a new printout for that. Now, of course, it was in Hindi, written down in Hindi, so not that easy for me to, maybe just type it out on a Word doc and then blow it up. Plus, it was like 8 pages long, back and front, if folks know that phrase. But it was a lot of content that I had to manually edit. But then I wanted to give it a shot. I just opened up Google, a camera, tried to take a photo, then went to Google Photos where it got uploaded, tried to do a printout and do some stuff. Stumbled upon something super interesting, and that is basically what I want to show you in this demo. Okay, so on the left is a Google Doc. On the right is my iPhone, right? And this is basically where it is. So I open up Google app, or the Google search app, which also has Google Lens in it, on my iPhone. And let me pause it. So that is the text, right? So that is something I've written down in Hindi. I did not intend to stress test the image recognition algorithm. My handwriting is that bad. I had to cut it out and do stuff. I realize I'm writing Hindi probably for the first time after college. So excuse me for the bad Hindi, but then Google Lens did a good job at it. So there it is, Google Lens, where I choose text. It has detected that there is text on that page. I am now able to select the text. And this is where I found something really interesting, right? There was a button that showed up at the bottom saying copy to computer. I'm like, okay, fine, let's not do that. Okay, let's get this demo rolling again. Okay, so I selected the text. I found this button that said copy to computer. Click on it. It did tell me which other computer I was online on. So it will show up that I am online on the MacBook, which is what is there here. So I say copy to MacBook. It says copied. And I wasn't expecting anything more than this, right? So this itself was surprising, like what's happening? And then when I come here, I just pasted this, and the entire text comes up, right? So whatever I copied from my phone, without the phone being connected to the laptop, shows up on the computer. Cool, did this, took photos of all the 8 pages, put it on Word, took a printout from my mom, everyone is happy, the event went on fine. But this got me thinking, right, and this is sort of the basis for the talk, as I mentioned. I was thinking about what is happening here behind the scenes, what are all the technologies that's happening here, and this is basically what I want to talk to you about. Keep this in mind. I will refer back to this demo as we go forward. So let's talk open source. That is this conference all about, right? So other way to start, Dan. All right. Now, we know open source has become mainstream in today's software world, right? And Google is no exception to this. We use thousands of open source products all across our development, our internal infrastructure, and our products. As participants in this open source ecosystem, our intentions are twofold. We want to give back to the community, right? Because we are using the software from the community, so we want to give back to the community as well, as well as extend support for the open source ecosystem. And we are really firm believers in this whole concept of open source. Why did we embrace open source? How did we start? In fact, if you don't know this, Google has been an early adopter of open source since the last 20 years or so. We have used open source right from the beginning to support our business on several fronts. Right at the beginning, in the 2000s, when we were in this hyperscale growth mode, right? We needed our infrastructure to keep up with the ambitions that we had as a company. We started building our applications using Python on Linux. All our systems ran Linux back then, right? This allowed us to actually achieve our business goals and work towards the scale side of things. The advantage of using open source was it gave us the autonomy and control. We were able to actually build things that we wanted, use the products that we wanted, and use the technologies that we wanted. We were not tied to any vendor. So we had complete vendor independence by using open source, and we did not need any of them to actually meet our company's needs, be it hardware or software, by the way. Also, the open source licensing flexibility allowed us to adapt the software to our needs, right? We were able to take the source code, make changes, use it the way we wanted to, and of course, contributed it back. This, in fact, helped lower our total cost of ownership, right? Because we started building with open source. And finally, we were able to innovate faster because we were actually using the software. It is not just the Google developers working on the software now, right? By using open source, we actually tapped into the global talent pool, the global developer pool, who are building out the software, the open source software, and maintaining the software. How many of you recognize this logo? Yeah. Anyone that doesn't? This is, of course, Kubernetes, right? Now, I'll tell you a short story about this. Again, if you've not heard about this, we have written a lot of blogs and papers around this. But Google has been running containerized workflows in production for more than a decade, right? Whether it is services, front ends, stateful servers, or batch jobs, everything at Google, almost everything at Google runs as a container. Back in 2015, and this was actually called Borg, right? So back in 2015, we took the wraps of Borg. Borg was long rumored. Everybody knew that Google was running something like this, right? So there were a lot of rumors around this. But this was our internal container-oriented cluster management system. And we actually published a paper around this, right? We published an academic paper around Borg in 2015 to explain what this was. And soon after, we actually created this Kubernetes, right? We forked Kubernetes out of the way that we built Borg and donated it soon after to the Cloud Native Computing Foundation. So that is how we started off with Kubernetes, or that's how Kubernetes started off. In fact, some of the developers that were assigned to working on Kubernetes, building Kubernetes out, were developers who worked on Borg itself, right? So they brought the learnings from Borg into Kubernetes. And in fact, some of the pain points that we faced while we were running Borg was incorporated into Kubernetes. Right? So that is basically what we're doing. And of course, we have continued commitment to Kubernetes. Today, Kubernetes is the industry standard for cloud native or container orchestration, container management. It is the largest CNCF project with over 35K contributors working on it. We are, of course, deeply committed to this project still, even though we have made it open source. We are still the #1 contributor to it. We hold the most leadership positions for this project, right? So that we are able to influence the direction and influence, make it more useful and usable by everybody, right? And we have our folks working on it as well. In fact, we are so committed to the success of Kubernetes that we even donated Google Cloud credits so that Kubernetes development itself can be done on Google Cloud, right? So all the folks, internal and external, that are working in Kubernetes can run Kubernetes, can develop Kubernetes using Google Cloud itself. Now, some stats in terms of what we've been doing for open source, right? So this is from 2020, and this underlines how committed we are to open source. So close to 10% of Alphabet employees have contributed to open source in 2020. We created more than 2,000 public repositories and totaling up to 10,000 plus repositories that we have created and that we have published out there. Most of them on GitHub, but we also have our version of Git that runs on Borg. So we call it Git on Borg. So we have repositories on that as well. But all these are publicly available and open sourced. The employees of Alphabet have interacted with more than 75,000 registries that are there in the open source domain. And we have contributed to it by either pushing commits, maintaining this, or creating pull requests. In 2019, or year on year, we have been growing our engagement with the public open source repositories by about 25% year on year. And as of 2020, there were about 75% pull requests that were made by the Alphabet employees. 75% of these pull requests were made not only to Google repositories, but also to other open source repositories, right? So that is the kind of, let's say, the culture or how we encourage Googlers or Alphabet employees to focus on open source. Now, open source is not just about Googlers working or Alphabet employees working on open source, right? We also want to inspire and foster a culture of public contribution to open source, and that is where the Google Summer of Code came up with. Google Summer of Code is essentially an online global platform for bringing new contributors into open source, and we work with open source organizations on approximately a 12-week programming project under the guidance of mentors. Over the last 15 years, we have seen about 15,000 students contribute to open source through this program. We have onboarded about 25,000 mentors from over 100 plus countries, right? And this basically group that is working on the Summer of Code has contributed to more than 680 open source projects until now. Some of the goals of the GSOC program are to inspire developers to actually adopt open source, right? To start contributing to open source, encourage them to do that. That is the first and primary objective. We also want to help the open source project maintainers to connect with these developers, right? Find new developers who can actually help them maintain these projects. We want more and more open source code to be written, right? So that we have code which is open source and it can be released for the benefit of others to consume. We also want to give new developers, right, like students or young professionals, to get the experience of working on real world developments, right? So by working on open source projects, they get experience of, for example, distributed development, version control, how does that work, software licensing issues, testing, and communication, stakeholder management. All of these are some of the benefits that they get by working on these programs, right? And this is even before they actually go into their professional life and start working on larger software. But it is not just about writing code, right? We have been talking about open source as code until now. It's not just about that. Google has played a key role in shaping the whole big data open source ecosystem. Sometimes this is sort of the timeline the way it looks like, but back in 2003, we released 3 very influential papers. This was Google File System in 2003, this was MapReduce in 2004, and Bigtable in 2005, 2006. These were very influential papers, and once these papers were released, these were our research of how we conceptualize this or how we ran this at Google, and this served as an inspiration to several open source projects, right? And things like what you see here, in fact, things like Hadoop, Hive, Spark, many of these projects were actually inspired by some of these papers that we released, and these projects were created. Google even contributed back to these projects, and we released additional projects to support these concepts, like Kubernetes, TensorFlow, Apache Beam, and so on. So talking about data, we spoke about source code, we spoke about how there are different projects, software that can help you work with data. The data itself is super important, right? There's generally been an ongoing debate, and I think many of you would have seen this about the value of data, right? How important data is, and whether companies, the large internet companies should do more to share their data with others. At Google, we have long believed that open source and open data go hand in hand. Right? It's good not only for us, but for the industry as a whole, and it benefits the world at large. So we have always been very committed to contributing data back to the society. These are, for example, some of the data sets that we had, right? So we have shared many data sets, services, and software with the larger world. For example, we released the Open Images data set. This is a data set of about 36.5 million images, and it contains about 20,000 human-labeled categories of objects. Right? So this is a massive data set, and with this data, computer vision researchers can train various systems, right? Like image recognition systems, and also we have that's for the image recognition. We have the YouTube 8M data set as well, which can help you train video recognition systems. We have also made available things like what is called the trillion word, that should be the word corpus, there's a typo there, so the trillion word corpus, which is based on basically the public web pages, right? Sort of what we do in Google, right? We index web pages. So we have the corpus which is based on all the content in the public web pages. And also we have the Ngram viewer that can be used to explore more than the 25 million books that is available in Google Books. These collections are very useful for language learning and training purposes, right? For example, you can do statistical machine translation, speech recognition, spelling correction learning, entity detection, information extraction, and all other language researchers use these datasets for those purposes. These are only a few examples. I would encourage you to go to some of those links there, the research at Google and tools datasets to look at these datasets. We also have Google AI. So Google AI currently lists about 62 datasets of this sort, right? This is just 4 of them that I've listed here, but there are 62 such datasets that we have made available to the research community. Not just research, but before we go to that, this is the Ngram viewer that I spoke about, right? So did a random search for instances of occurrences of Frankenstein and Einstein in books. Who knew Frankenstein was more popular than Einstein? I mean, that was a revelation. So as I said, we have contributed all those datasets to research, but we also have a number of publicly available datasets as well. So for example, the 20,000 Kaggle dataset. This is available for machine learners, data scientists to go and play around and experiment with. We also have the cloud public datasets, which is available, which allows people to access frequently used public data directly from within their data engineering or data science workspaces. We also offer Google Trends. Google Trends is a service that enables anyone to see and download the aggregate search activity. And this is activity since 2004 that we have made available here. This consists of activity across Google Search, image search, news search, shopping, and YouTube. According to Google Scholar, right, where most of these research papers are published, there are more than 21,000 citations to Google's Trends. Right? So people have actually used the data from Google Trends to build out their research papers. We have also published about 5,300 research reports that were actually written at Google, and these have also been, these are available for you to go and take a look, but many of these have also since been published in scientific journals as well as in conferences. This is essentially what our commitment is to opening up the data that we have, right, and making it more accessible to everyone else. Additionally, this is data. How do you actually use this now? So this is yet another project, TensorFlow. TensorFlow is something that we released in about 2015, and this continues to, we continue to lead this project as well as contribute a lot to this project for the developers and users. Some of the stats were in 2021, there were close to 200 million downloads of this project. There were 52 million tutorial views, right? So there are so many learners who are actually trying to read this, read the documentation and understand how to use this project. There were 9 million plus articles around TensorFlow that were read. We have close to 1 million subscribers or 1 million learners on Coursera, where we have created content around how to learn and use TensorFlow. And many, many active user groups who are working on TensorFlow. Okay, so I wanted to tie the demo back in together, right? It was not just to show something cool. What do you think you saw in the demo? What was one of the standout features that you saw in the demo? Recognition, right? So character recognition, right? Machine learning, character recognition, could be handwriting recognition, which is something that I did. How can all that be done without data? Imagine if you didn't have the data to train your systems. You need tens of thousands or hundreds of thousands of data sets to actually train a good model, right? To be able to recognize such kind of writings and such kind of texts. An individual or a small company cannot get access to this. So data is very, very important for you to actually build these training models, right? Also, if you look at it, if any of you have done your machine learning, right, you typically start, if you do something like the CNNs, right, convolutional neural networks, you will start with existing models, right? There are very famous models like ResNet, VGG, AlexNet, a few things that I have used. But these are models itself that have been made publicly available. If you did not have these models, and even if you had the data, if you had to learn from scratch, imagine how long it would take to actually learn and how much computing resources that you will need to do that. So it is very important for us to share information, and by doing this, we are able to directly impact innovation, right? So this kind of innovation impacts our lives, as you see, this thing that actually helped me out a lot that day, right? So the openness in the software world, openness of data, openness of sources, openness of software is what actually helps us move our innovation forward. Questions of time? Yeah, okay. But of course, right, this is a lot of effort. It is very expensive to compile this data, share this data, maintain this data. So why do we do this at Google? Various other companies do this, right? I'm not saying Google only does this, but this is our philosophy of why we do it. We have always had this long-standing mission as Google, right? To organize the world's information and make it universally accessible and useful. This has been our primary mission, and how better than to make information universally accessible and useful than by giving away the data, giving away the information, right? So that is what drives us to do this. Getting these materials, making it available actually helps stimulate scientific research outside of Google. We at Google cannot do everything, right? We spend a lot of time reading, understanding, and often extending the work that is done by the community. And this community in turn has done this work or built their progress on some of the data and on some of the software and tools that we have released and made publicly available, right? So this kind of a collaborative, it could be competitive, but it's also collaborative, right? This kind of a collaborative effort is what actually helps push science forward or push innovation forward. And this is something that we firmly believe in, which is why we do this. Another reason is when we hire employees, it is useful for us if they can hit the ground running, right? If they already use the tools that we have, if they already use the kind of software that we release, that we work on, they become productive right from the first day, right? So as a company, as Google, we can become a lot more productive. So this is another reason why we actually make it available so that folks can learn to do things the Google way, right? The way that we build and we use software. Of course, very important, we cannot release every single data that we have, right? So going back to the whole question of should companies open up their data and things like that, because we need to also protect user privacy, right? User privacy, confidentiality of the business partners that we work with, all of their data is very important. And even Google's own intellectual property is very important. So we cannot publish every single thing that we have, but subject to these considerations, we do try to publish as much information as possible so that folks can make use of it. Let's look at open cloud. Now, open source has been the foundation of Google, right? It's been the foundation of our infrastructure, and we believe that the open source is also the future of public cloud. Open source approach is basically 20 years of what we've been doing. Can be credited to open source, right? So it is the underpinning of how we have operated at Google. Right from day one, open source gave Google the autonomy and control and the ability to scale out. And this is exactly what we want to give back to our customers, right? We want to help them achieve their business goals and give this back to them and give them the ability to work with open source and an open ecosystem for whatever they're building out. So the open cloud, basically what open cloud means for us, right? It's the ability to bring different physical locations together. So you'll be able to build your applications on-prem, on various public clouds, multiple public clouds, or on the edge, while leaving the operational governance and other aspects of the services to Google, right? That is something you don't need to worry about. We essentially look at your empowerment where we allow you to develop software faster, innovate more easily, and scale more efficiently. Open cloud definitely relies on open source software, right? So the leadership that we have built in open source software is something that we put back into open cloud. So projects like Kubernetes, what we spoke about before, TensorFlow, and many more, right? So all the software is something that we actually put back into Google Cloud. And we give you the flexibility to actually run your apps, right? We give the flexibility and portability. You can run this on Google Cloud. The same open source software that is publicly available runs as a managed offering on Google Cloud. Or you could just run it by yourself, and it gives you the portability to move anywhere else that you would want, or run it anywhere else that you want. Managing infrastructure, right? Anthos is something that we have recently released as well. This is a modern application platform that essentially extends Google Cloud, right? So extends Google Cloud services to hybrid and multi-cloud environments. It delivers, again, portability for you. You don't need to run only in Google Cloud, but you take care of all the operations aspect using Anthos, and then you can run it on any location that you want, moved wherever you want. We also embrace a partner ecosystem. It is very important for us to make these open source software available on Google Cloud in a non-competing way, right? So we actually embrace a partner ecosystem instead of competing against them. We make all these products available as first-class offerings on the Google Cloud Marketplace. We offer them as managed services, so we take care of things like upgrades, reliability, availability, all those things is something that we take care. But the software itself is open source software that you're used to, that you're familiar with. And we also share part of the revenue that we get out of operating that back to the partners, right? So we have an arrangement with them where we also help them, right? We encourage you to use some of these things on Google Cloud if you would like to. But then we also, it's not just only us that is taking the benefits of it, we also extend the benefits back to our partners. This is basically our philosophy around open cloud, right? And how open source is actually helping us drive this vision and concept of open cloud. So again, going back to the demo, I was again thinking about a few things, right? If you see what I was doing, there was a lot of portability and flexibility that was demonstrated in that. I was using an Apple iPhone in that case, right? If you saw. There was a Google software that was running on iPhone. There was a separate system, the Mac, which is still an Apple device, but it's an entirely different system that is sitting elsewhere. And there was no physical barrier, right, or no brand barrier that prevented me from doing what I wanted to do, right? I was very easily able to do what I wanted to do as an end user, copy text right from the mobile to the laptop, and do things that I wanted. And this is the power of interoperability and openness that we should actually strive for, right, in terms of whatever we do. Give you a little bit more example of how, again, we think about this whole open source and open cloud concepts. So we strive to be leaders in the cloud native space, for one, right? So we continuously innovate and work on software, try to improve the experience for the end users. For example, this is sort of, let's say, a timeline, right? We started off with containers. Containers started a while back. Containers, what it did was it solved for portability. You bring in your dependencies, you bring in your operating system, and then you run it. Right? So containers solved for this in terms of enabling DevOps, and you don't need to set up the whole infrastructure, virtual machines, all those things. But then how do you actually scale across servers? Right? You still need to scale your systems horizontally. And this is where we started why we brought about Kubernetes. Right? So Kubernetes solved for day 2 operations. Essentially, you have multiple servers, you build a cluster of servers, you have your containers that can get deployed very efficiently on any server that has the capacity. Right? So Kubernetes takes care of all that for you and removes this server boundary. Our leadership with Kubernetes also inspired us to make Kubernetes available as a managed offering on Google Cloud. So if you don't want to install and run Kubernetes by yourself, you have Google Kubernetes Engine, right, which you can use on Google Cloud. Now, once you have these services running, imagine you have hundreds of services running on different clusters, on different machines. How are they talking to each other? What if one service goes down? Right? How does the service that is calling this target service know whether the service is running or not? Which server to reach out to, right? It can't send the request to every single server and have everything respond, right? So it needs to reach out to something which is most available, highly available, least latency, and so on. And this is what is managing microservices. So which is where we worked very closely with other cloud companies, other companies, to release Istio. Right? Istio helps solve microservices at scale. It takes care of all this, abstracts away all this complexity of services talking to each other. All this is fine. We had Kubernetes, we had Istio, and Istio, by the way, is available on Google Cloud as a managed offering called Anthos Service Mesh. So all of this is available. Either you can use open source versions, or you can use what we have, the equivalent versions of it as managed source. But then we started thinking, right? We just want developers to write code. We don't want them to worry about all this infrastructure, who's talking to whom, managing servers and things like that. And that is when we said, okay, let's work on this thing called Knative. Right? So Knative solved for serverless. It gives you the same flexibility and comfort of working with containers. You still work with containers, but all the infrastructure aspect is completely removed from that. Right? So that is what Knative comes in. And Knative is available on Google Cloud as an offering called Cloud Run. So essentially, it's an ongoing journey, right? We're always looking for ways in which to solve the challenges the industry is facing and make life easier for developers. Quick background on Knative itself. So this is quite recent. In 2018 is where we released Knative. We have about 768 contributors as of 2020. And of course, we are part of the trademark committee. We lead some of the steering committee and the progress of Kubernetes, the contribution, of Knative and the contributions to Knative. As I said, this is available as a managed offering called Cloud Run. I would love to probably sometime do a demo for you of that as well, but then it's very easy, right? It actually democratizes the whole container management, container operations thing. You just focus on your code, give it to Cloud Run, and it runs it. Quick overview of some of the way that we have built our software. Right? So many of the products that we actually have built and that we run on Google Cloud actually stems from an open source alternative. We either have built it and then we have open sourced it out, or we have open sourced it and have run it as a managed offering, or we actually use industry open source concepts to support some of our projects. Whatever is starred here, and a good number of them are, is actually where we have created these projects by ourselves, but we use a fair amount of open source projects as well. And it's not just on the cloud. There are various other open source projects that we actually maintain, right? Which many of you are familiar with: Angular, Flutter, Go language itself, the language that powers Kubernetes. Right? That is also something that we built and we open sourced out. Awesome. So with that, I will come to the end of this talk. Essentially, I wanted to inspire you about open source. Go beyond source itself, right? It's not only about source, but go even beyond that. Openness in terms of adoption, openness in terms of ecosystem, open data. This is what we should strive for, right? So by being able to collaborate effectively is where we can actually innovate more, we can take our progress faster, right, and make lives easier. Final thing, we do publish a lot of this content out there. This is a QR code that will link you to opensourcelive.withgoogle.com. You can take a photo of it or you can scan it and click on the link. But we regularly share all our knowledge and information around open source in essentially two forums. One is around education, right? So opensourcelive.withgoogle.com is where we publish a lot of education material. We also publish a lot of videos on our YouTube channel called Google Open Source. We also provide a lot of open source insights and contribution updates on our blog and the Twitter handle that we have. So invite you folks to take a look at this, be a part of this as well, right? So join our community, join the kind of effort that we are creating in terms of open source, contributing back to open source, and be a part of this. Awesome. I'll leave the QR on if you still want to scan, but we probably have 5 more minutes, and if there are any questions, I can take that.
So Google developer advocate, I think you are one of the people to actually, this is a concern.
Yeah.
And this is with regards to Android.
Okay.
So let me just clarify. This is issue number 369499085.
That's a big number, okay.
Yeah, the headline is support for DHCP v6 RFC 3315. Date opened June 3, 2012. Status won't fix. As far as I know, there have been almost 1,000 requests on this comment till now. But nobody from Google wants to implement a functionality that is part of the IETF RFC, supposed to be in IPv6, and prevents Android from being used a lot in the enterprise markets.
Got it.
So, I mean, that's something that, and this is not that it's been I'm not the one who's saying it.
Sure, I understand.
It's been, so I do not know what's happened. There's another personal peeve I have with Gmail, but I won't want to talk about that right now because it's just the interest of time, but I just wanted that somebody in Google should be listening to these things.
Absolutely, yeah.
And if you want, we can connect offline or I can
tell thank you so much for bringing it up, and maybe you can just repeat that number. I'm just making a quick note of it here. But yes, and that, as you said, right, this is basically what I do. As an advocate, for me, it's important for you to be able to be successful with the products and the things that we build out. 364
36949085.
9085. All right, perfect.
It's been a won't fix intended behavior. I'm not sure how.
Sure, no worries. No, thank you for that. I'll note it down and make sure that it reaches the right folks who need to look into it.
As you know that basically to train a machine learning model, you have to collect an immense amount of data.
Yeah.
And Google has been harvesting data since like long. Is there a way like where we can train a model or build a model with a very limited amount of data and not even like, how to say this, collecting small amount of data and which is not privacy centric or breach the privacy, and still you can make a good predictive model?
Sure. No, and absolutely right. And this is basically what I had mentioned previously about this open data set, right? So I would really encourage you to search for open data sets on google.com, of course. Search for it there. You will get access to all the data sets that we have made publicly available. If I recall, the number is close to 32 million images that is made available there, right? That is one thing. So the way that you do it is you need data because otherwise you'll end up overfitting your model, right? So you need a wide variety of data. 2 ways, use the publicly available data sets that we have. It's free, so nothing is paid for, right? So you can definitely start using it within your training algorithms itself. Also start off with, let's say, neural networks that have already been trained, right? So that you can specialize it for your specific use cases. Google's neural network is also there, model is also available. But like I said, there are popular ones like AlexNet and ResNet and others that you can start off with. So these have already trained on this huge corpus of data. They understand how to, let's say, view images, right? And then you can train it for your specific use case from there, right? So yes, you need to solve for the availability of data to train your models, but then one, use the publicly available corpus, or start from progress that's already been made. That will help you a lot.
Good morning, sir.
Hi.
I work on brain diseases, especially epilepsy. So I had a question regarding latency. Right, I am taking the real-time data from the epileptic patient on a cloud, right? And it is going every second, and it is then it is sent to a smartphone, Android, right? And in that, the machine learning model is embedded, which finds that as soon as the attack will happen. But I just want to know that about how that there will be some latency. So how, because there should not be any, in order to prevent the attack, we want, it will, we can, with our software, can only predict epilepsy 10 minutes before. So how is your cloud and other facility services given by Google would help us out?
Sure, thank you for that. So I think, again, we can probably connect offline. I can share some of the details about what we have that you could use for this. General thing, and I think if I understand what you mentioned, right, you have your model probably on a smartphone or let's say a low-powered device, right, that needs to be able to detect. So it cannot run all these machine learning algorithms or the actual prediction on that device, which is where you will have to use transfer learning, right? So you can use some of the products that we have to actually build out your models, refine your models using data that you already have, right, like past patient history data and other things. So build out the models, transfer the learning, export that model out here. You can also serve models as over cloud, right? So you don't need the model to completely be present within your smartphone itself, but you can serve it over Google Cloud, right? Using the GPU instances that we have available, which is really powerful and can run these models very quickly. So serve it out of there, and then consume those models from your smartphone where you're able to take a photo and is able to detect things from that, right? We have a lot of papers around this, how we have done things. I think diabetic retinopathy is something that I remember that we have done. We have published the papers around that as well. So I can share you pointers to some of how we have done it. I think it should definitely help. But then thanks for working on this field. I think it's very important.
Hello, good morning. So my question is around this open source. So like, while you adopt open sources as a managed service and all, what are the other key responsibilities that you also guarantee as a part of service? Like essentially around the vulnerabilities and all those things. Do you ensure that these have like minimum things that is available, and also like other than that, what else as a service guarantee that comes on the board?
Sure, absolutely. And this is where managed services actually help you a lot, right? So, see, there are two things, right? What is our thinking behind this? We want to offer you the flexibility and portability. Right? Please sit down. Right? We want to offer you the flexibility and portability to either work with Google Cloud or use the same thing that you've built out anywhere else that you want, maybe on your own machines, right? So that's the whole idea why we support open source so much. But the actual advantage of running something on Google Cloud or running it on a managed service provider is exactly what you said. Things like security concerns, the moment vulnerabilities are detected, we in fact have a huge team that looks for vulnerabilities and actually scans open source software. I did not mention that here, but there's a project called OSS Fuzz. OSS Fuzz actually runs on every open source software out there in the world, scanning for vulnerabilities on like a real-time daily basis, right? All that information comes to us, and the moment we see that a fix has to be made, we will make the fix behind the scenes without you being impacted as a consumer of that software. Right? So being able to take your mind away from whether there's a vulnerability, there's a security issue, taking your mind away from scalability issues, taking your mind away from operations, right? How large should my server be? How should I scale up? Should I scale down? All these are the benefits that you'll actually get from running a managed offering.
Recently, there was one conference of yours when one of your developers, I don't know who, they had launched a new programming language called Carbon. And they advocated that as an effective replacement for C and C++. Now, these are like one of the fundamental languages in the programming world. Now, where do you want to replace C and C++ with Carbon? That's my question.
Sure. I am not from the team, but I definitely do know. There are folks who, see, when somebody works on a language, they're very passionate about it, right? You need to determine what to use. As a developer advocate, I basically help a lot of folks understanding where they start off their programming journey or their software journey and other things as well, right? So I have my own perspective. Use the languages that suit well for your needs, right? For example, why did we create Go? We created Go for a specific use case, right? Managing server infrastructure was a lot more easier, less overhead when we actually used Go, right? As compared to some of the other languages that we were using back then. So various languages are built for specific purposes, and it is not fair to a language to say, this is the next generation of that language and you should be replacing it, right? I mean, C and C++. There are people who still use C and not C++, which is the plus upgraded version of C, so to speak, right? So, do your research, understand whether the language has the capabilities, benefits that you need for what you're doing, and then go ahead and use it if you think it makes sense. But otherwise, yes, just use whatever you're comfortable.
My question is, basically when you talked about companies exposing their data so that, you have still restrictions of what data can be consumed from the company and, what data can be kept private, specific to the company. So as a company, how one can differentiate on, or how you be so protective about which data to actually consume and which data to not consume in your activities?
Sure. See, again, I don't have everything in my hands. Right? Please sit down. I don't have everything in my fingertips right now, but what you can do is you can search for, we have on our AI blog, I forget the exact program name, but something about responsible AI or ethical AI, right? The way we do things. Essentially, the thing is simple. Things that we have used or things that are not user identifiable or doesn't expose the privacy of a user or a business, right, is something that we can make available. So for example, let's say a photo of maybe a dog on the road where you can, the model that helps you identify or do the, let's say, the edge detection of that animal from the environment is not infringing on any privacy. So we can also share the data that we have to learn about it, as long as, and again, there are privacy laws outside India as well, right? So pets, you have to take explicit permission of owners before you take pet photography and all that. Subject to all those conditions, data that we have available, the model of how we're able to detect these edges, the actual trained model itself. These are things that don't infringe on any privacy, and that is something that we are able to open source out, right? Make public available. But yes, that is basically what we should do, right? You shouldn't go blind just exposing everything out there and then creating a data leak. That is absolutely not something that we want to do, and we are very conscious of that at Google, because we have a lot of users' information. Only machines read some of these things, right? So no human is able to read any of this information. And this is basically the next level of abstraction where we make it available to others too. Cool. I'll probably be out there at a booth for a while as well. You can reach out to me there. And my clicker doesn't seem to be working, but as I mentioned, I'm also available on Twitter as @KSPrashu. Feel free to reach out to me there if you need anything, want to interact. Okay. Thank you so much. Been a great audience, and I'm happy that I came to this conference as my first in-person conference after 2 years. Thank you.